Hello, the day 18 of Advent of Cyber. Let's dive into the storyline and see what's happening in the city of Weville and see what we have today's task as. The story. Wereville has not felt right since the wormhole appeared. Everyone, the best festival company, is on high alert. Systems are going haywire, dashboards are spiking, and SOC alerts have been firing non stop. Amid the chaos, Mix Kitty keeps her focus on a particular alert that caught her interest. An email posing as North Pole HR. It's littered with carrot emojis. But weird thing is this, there is no North Pole human resource department. The best festive company's HR is at the South Pole. Digging further, she found a tiny PowerShell file from the email was downloaded. Amongst the code are random strings of characters, all gibberish, nothing readable at a glance. MixKitty knows malicious actors often hide code and data using techniques called obfuscation. But what is it really, and how can we decipher it? The learning objectives of today is to learn about obfuscation, why and where it is used, learn the difference between encoding, encryption, and obfuscation, learn about obfuscation and common techniques, use CyberChef to recover plain text safely. So, connecting to the machine, do I need to start a VM today? And is there a split screen available? That's there. So, let's click on Start Machine and let's go ahead with the challenge into the next task, which is obfuscation and defuscation. Deobfuscation. Don't mind with my pronunciation. Understanding the gibberish. Obfuscation is practice of making data harder to read and analyze. Attackers use it to evade basic detection and delay investigations. Let us say a security tool will automatically block any file that contains the word the bandit yeti. To evade this, the attacker can use simple cipher techniques called ROT1 to hide the strings. ROT1 is a cipher technique that shifts each letter forward by one in the alphabet. The letter A becomes B, B becomes C, and so on. Using the cipher caret coins go BRR becomes something that we can't really read, or it makes us difficult to read. So that's the thing. Now, if you have the word caret coin go BR, it is moved to DBSSPU, DBJOT, HPCSS in the ROT1 technique of encryption or cipher technique. Now, basically, to give you a practical scenario of where obfuscation actually comes in. Now, let's say I'm writing a malware. So, in those malwares, I'm going to be having a specific signatures that are going to be embedded into it, which can be detected by any antivirus or any of the malware detection softwares which is installed on the computer. Now, a practical way to hide the malware signatures that these malwares or antivirus are going to be identifying of the malware, I can change those functions or characters into an encoded or obfuscated format so that when the tool is going to be scanning for those exe files or the malware applications, that is not going to be able to figure out what the signature was exactly, because they are all encrypted or obfuscated in that format where it cannot be read by them. Only the application what it is going to be using for doing its malicious thing, only that will be knowing how to deobfuscate them and then execute all those malicious programs what are written for. So that's one practical case where a malware is going to be obfuscated to evade any of the antivirus or any such applications of it. Other places are if you want to send a secret messages to someone, you can use obfuscation also. But again, most probably it's used for hiding malwares or their functions or those command lines from any antivirus or malware detection applications. Okay, obfuscation in real world. So far, we have kept it simple. In real world, you'll encounter a wide range of techniques. One slightly more complicated technique you would be utilized is XOR. Each character is represented as a byte, and each byte is combined with a key using XOR mathematical operation. So if you want to learn XOR in detail, I can link the video. It's somewhere right or left. I don't know. It's going to be here. It is in one of the, again, Advent of Cyber challenge itself, where I've explained in detail about XOR, how it works, you even using binary encryption and decryption methods. So if you're interested in learning about XOR, you can check out the video. It's somewhere in right or left there. Let's get into the content here. No need to go into detail as how it works. The only thing you need to know is that this operation changes the bytes into different bytes, which something makes resulting text end up with the uncommon symbols or non-readable characters. Obfuscating with XOR is not something that can be easily done manually, but thankfully there are tools available that can help us with this. One such widely tool is called the CyberChef. Let's try to obfuscate a string using CyberChef by following the steps below. Open CyberChef visiting the link in your browser. Okay, let's open that link. At the top right, you will see an input box. This is where you can paste your text you want to change or obfuscate. In our case, it's going to be caret supremacy. Okay, so let's come here and into the input box there, we can paste the input that we want to obfuscate. Then it says in the left panel under the operation, search XOR and drag it into the middle under the recipe. This tells CyberChef to apply that technique to your input text. So coming here, let's search for XOR, drag it and drop it here. Now this is where we need to specify a key in terms of XOR. And basically the under the recipe just says what should you do with the input that you've supplied. For example, I want to XOR it, or let's say I want to base 64 encode it. So I can say to base 64 encode. So it's going to convert whatever input text that I've given into the operation that is specified here and going to give the output there. So right now we don't want base 64, we are dealing with XOR only. So we have added this function to the recipe there. Now going here, it says each operation has settings you can adjust. In our case, we want to set the key to A. So we are setting a key to A. Make sure that the drop down next to the key is set to hex. Okay, so we are setting the key, which is in case of XOR, we need to have a plain text, a key, and then the cipher text is going to be generated with that. So we have the input text, which is the plain text here, the caret supremacy, and the next one is the key, which we are entering here, and this is the cipher text. Now the type of standard text that we want is specified to be standard here, and we have also chosen the kind of ciphering that we want to do is based upon hex. So that's why we get such random things. If I change it to UTF-8, you can see a different kind of ciphering that is happening there. In case of base 64, it's a different one. Binary is different, decimal is different, and so on. So we are choosing hex here to cipher it there. The obfuscated result should automatically appear in the output section. If it doesn't, click bake at the bottom of the screen. Yeah, we have an option here called as bake. I feel this is like a kitchen where you have the raw material, then you have the recipe to what you should do, and then you make a thing out of it. So, I mean, that's just the theme of that web. As you can see above, the string caret supremacy now becomes this random character. That's good. Detecting patterns. The good thing about well-known obfuscation techniques is that it's easy to reverse it once you figure out the technique used. You can use these quick visual clues to guess the obfuscation technique used. Rot 1 is going to common words look one letter off, space stay the same, easy enough to detect. Yeah, in case of rot 1, what happens is, as it's already mentioned there, let's put this out and let's say rot 1. Do we have? No, we have rot 13. Rot 13 is also another example of it. So it's going to rotate the characters. So if I have A here, so A plus 13th character of A is going to be N. I'm not sure. A, B, C. Again, I'm not counting. But yeah, so that's going to rotate for the 13th character of it. So if I type in something like A, B, C, D, E, F, G, H, I, J, K, L, M, N. So now you can see here that we have rotated everything in a 13-bit length forward. For example, B is going to be O, then C is going to be D is going to be Q, and so on. So we have seen that rotation here. Now when I came back to N, the next character is going to be A. So again, it's not so easy to detect, but if you are capable of detecting it by reversing the 13 characters from the name, it's going to be identifiable. Basically, you can reverse it. Then comes rot 13 again. It's here. Look for three-letter words, common ones like the becomes GUR and becomes NAQ. Space says the same. So yeah, we can even show that. So the becomes GUR and becomes NAQ and so on. So using these common words that we already know it's going to come in any sentences, we can try to see if they match to any of these ciphertext. For example, the as GUR, if they are matching in a sentence, we can probably assume that it is using ROT 13. Next comes base 64. It's a long string containing mostly alphanumeric characters, that is A to Z in caps and A to Z in small characters, then from 0 to 9. Sometimes with plus or forward slash, then often ending with a equal to or double equal to. That's the thing. With base 64, you can easily guess if that was used or not because of the nature of the hyphen or equals to sign which comes at the end. For example, I can say, hi, this is me. What's this? Uh, from, no, not from. So we need to do it to base 64. So now you can see that that is equals to sign there. Now again, it's mostly if it is base 64, it's going to contain equals to, but there are other encryptions also which are going to be using equals to at the end. But base 64 commonly uses it. First case, when you see characters like this with alphanumeric combinations, you can assume it's a base 64 encoded text there. Then comes XOR, a bit more tricky, looks like a random symbol but stays the same length as the original. If a short secret was reused, you may notice a tiny repeat every few characters. Yeah, XOR, let's also again try here. Hi, this is Pranava here. Please sub to this channel. Yeah, we can try all these methods now. This is base 64. Again, it's random long characters. If I go for X or drag it and drop it here, let's set the key to be YouTube. Okay, so we get this character there. Now, let's say I start typing again, saying hi. Uh, this is Pranava here. You can see there's a repetition of the characters and combination. The length of this also remains the same. So that's one way to identify it. But again, mostly when you see such things, and if this is with the memory blocks or something like that, we can't usually identify it's an XOR encryption. When it comes to decimal, there is no changes. What about UTF-8? Yeah, this also seems to have something here. If you encrypt this in between images, obfuscate them, hide them between images, we can't really identify the XOR encryption there. Okay, once you have a guess on what cipher was used, you can go back to CyberChef, but this time use an operation that does the reverse effect. For example, to deobfuscate base 64, use from base 64 instead of to base 64. Yeah, we can do that. Let's remove this and say first let's encode it. So to base 64, let's drag it and drop it here. We get this long text. Let's replace that there. Now let's put from base 64. Oh, not base 65, sorry. From base 64, drag it, drop it. We get the original text back. So you can do the reverse also in all of these cases. ROT 1, 13 or XOR or even base 64 there. So unfamiliar partners. Not sure what you're looking at, it's fine. Even if you don't have an idea of what cipher was used, it is easy enough to keep on trying different operations just to see if the text becomes readable. CyberChef also includes an operation called Magic that automatically guesses and tries common decoders for you. To use it, just add Magic operation and look at the result. It will display multiple results and it's up to you to check which one ends up making sense. You can even check intensive to make sure it tests more possibilities before giving up. So let's try this. I've never tried Magic in CyberChef so far. So Magic. Uh, am I typing? Okay, yeah. Uh, yeah, so it gives recipe click to load. Okay, it's trying base 64 here. Let's increase here. Properties possible language. Okay, here it is trying base 64 again. So it has tried with base 64 and it has given some output there. Let's add some our own text and see if it's going to try anything. Uh, okay, so it did not. So it has some. Okay, it is not able to identify it, but also talking about entropies in it. Wow, that's nice. Entropy is the randomness in that. So yeah. What if I give depth to be like this? What is 10 depth? I'm not sure. Okay. Another one was intensive. What was it? Intensive mode. Oh, it is in magic itself. Okay. So magic and intensive mode. It's going to try a longer combinations of it. Okay, that's good. That's nice. But again, this was we get some Chinese language here. This is Japanese. Again Chinese. I don't know what these are, but they also seem to be giving some output there. That's nice. Wow, that's good. Okay, that's nice. That's valid. Fine. Let's continue with reading here. Layered obfuscation. To make deobfuscation harder, threat actors would often combine multiple techniques, almost like a layered approach. For example, a script that threat actors want to hide can be compressed with zip or XORed with X key, then finally base 64 encoded will produce this obfuscated string. We have this big string here. Okay, to reverse this kind of layered obfuscation, apply the operations in the opposite order. Base 64 decode XOR with X, then decompress gzip. The screenshot below shows how to chain these operations to recover the original content. So from base 64 XOR and then gunzip. Let's try that. I've copied the content, pasting it there. Let's do base 64. No, let's try what magic does here. I'm interested with magic. It has what was the output here? It says get child item with some Windows PowerShell stuff. Uh, okay, we don't see any fruitful thing. I guess this is XOR one. Good. This has identified the XOR. Uh, okay. So this has identified XOR there. That's nice. Now what if I add magic again here? It's going to say gun zip. That's good. Uh, okay, let's put it as X here. If we'll get anything. Okay. Fine. This doesn't actually give. It says gunzip is there. Oh yeah, we get it. That's nice. So we didn't have to XOR it. Okay, magic did something. So if I do XOR and run this here with a key X, we get this output. Now if I G unzip, basically, I'm calling it as gunzip. But yeah, we got this result even before XOR, right? Yeah. So magic does it. That's the thing. Okay, that's nice. So we get that output there. Unwrapping the Easter egg. Luckily, Mix Kitty detected something fishy in the email we received. She extracted a PowerShell script from the PDF and put it on an isolated VM to figure out what it's doing. There is some obfuscation in this script. Can you help her understand what it is? Open Santa Cipher Stealer.PowerShell located on the VM's desktop in the Visual Studio by double clicking it. Take a moment to open. So let's open this in Visual Studio Code. Then, okay, follow the instruction in the code's comments and save. Then run the script from PowerShell terminal to get your first flag. Okay, so navigate to start here. So where is start here? Fine. Start here. Okay, start here is right there. So we need to follow these steps. Follow the instructions in the code's comments and save. Then run the script from PowerShell. Okay. Start here. Part one, deobfuscation. To do step one, deobfuscate the string present in the C variable. Okay, we have this variable and place the URL in the C2 variable. Okay, then run the script. So we have this one and this one here. This looks like a base 64 encoded character. Let's copy that. Open up cyber chef. Okay, so while that is doing from there, what we can do is we can do it here itself. So we can remove this gun zip. Okay, so basically I had an issue with my recording, so that's the reason this is a cut of it. Yeah, so nothing, but we just pasted the base 64 character here, and we get the from base 64 operations we get the URL there. All that we have to do is then replace the URL here in this place and then run it using PowerShell there. All that we get is the flag. After we get the flag, we can come back to the place here and then submit it. Now we are up to the second challenge. It says part 2 is obfuscating. So to do obfuscating the API key using XOR single byte key. So this is what you're supposed to be XORing with, and convert the hexadecimal. Then add the string to this variable here, then run the script again to receive the flag 2 from the validator. Okay, that's good. So what we have is we need to take this API key. It says candy cane API key. Let's copy that. Coming here, let's replace the input with the API key. Drop this back to the operations. Now search for XOR. Paste this in here. Now for the key, what we'll do is we'll copy this, paste this in here, and we get this random text. So let's copy this random text and hopefully I can paste it here. No, see, that's the thing with this, that I'm not able to paste it to the screen here, nor it's loading for any cyber chef here. Okay, the another best option is to RDP into the machine. They have given the IP here, so let's copy this IP address and then RDP into it. So I hope I have Ramina installed. Yes. So with this, I can, we have one instance here. Let's close this. Let's edit this and paste the IP address and username, password, nothing. So no username, no password. Let's click on save and connect. Does that connect, or do we need to go up here and then get the credentials of it? Yeah, it's there, no? Administrator, cancel. Let's edit it again. Username is administrator, password is this. Okay, that is done. But before that, we need to also connect to their VPN. So sudo open VPN and is it this? Yes. Initialization sequence completed. That's good. So now let's click on save and connect. Yes. Oh, it's done. It's coming here. Hopefully now I can paste whatever I want. Yes, I can paste it. That's good. Let's close this. Let's close that also. Let's copy this and paste it in here. So we get that obfuscated candy using the key. What key did we use? We used this key itself, right? Okay, this is done. Let's save this. And can I set a frame which is full screen? Is it possible? Yeah, it's possible. Okay, so we get the hex there. So let's save that. Then run the code again, Santa Stealer.ps1. It's downloading the payload. We'll get the first flag. Then for the second flag, we need to wait. Hoping it to get the flag. Okay, we got the first flag. Is it the same? Is it the same? Let's check it here. Yeah, this is the first flag that we got, yes, but we did not get the second flag. So let's come back to the code here. It says obfuscate the API using XOR single bit key using this and convert it to hexadecimal and then convert it to hexadecimal. Oh, okay. So let's come here. We have uh, done this. Okay, we have taken the same thing, right? A single bit, a single byte key, this. Again, keys also mentioned here and convert it to hexadecimal. Then add the hexa string to this variable. We have added the hexa. Are they talking about hexadecimal here? Is it this one? Let's try. Uh, None. No, I don't think so. Are they talking about this? I'm not sure. So why not give it a try here? Let's try this. Coming here to the PowerShell, run the above script. So it's going to give the first flag. That is obvious. Then let's wait for the second flag to also show up. Yes, we get the second flag also. So we were supposed to also do the hex thing there. Fine. So we get the second flag. Let's copy that. Come back to the browser here. Paste this here and click on check. That's done. That's great. What else did we have? I guess that's all with the things there. So let's click on check there. And with that, we have finished the day 18 of Advent of Cyber. Let's dive into the day 19 of Advent of Cyber in the next video. So till then, stay happy, stay smiling. Thank you for watching. See you in the next video. Bye bye.